Hello guys, so we have a problem here. So in order to formulate the forward kinematics model of a 3 degree of freedom for a cylindrical arm manipulator, we have that is shown in the figure. So here is the 3 degree of freedom revolute prismatic and prismatic cylindrical arm. Okay, so he has given directly the cylindrical arm, so he has mentioned as revolute prismatic and prismatic. So that means we will be having one revolute joint and two prismatic joints. Okay, so here is the diagram he has given us, so don't worry, we will be assigning the frames first, later we will be going for DH table, and last we will be calculating the transformation matrices. Okay, so that is the procedure. So we will be having the joints 1, 2 and 3, and we will be having one face plate attaching to that. Okay, so we have to assign the frames for the 3 joints. Okay, of course we have to assign the frame for tool also. So mainly concentrating on the revolute and prismatic joints. Okay, so the cylindrical configuration of a manipulator that having 3 joints. The first joint will be the revolute joint, while the next two are the prismatic one. The axis of the first two joints coincides because this configuration has a cylindrical workspace as discussed in the uh, question. So as we will be beginning with the fixing the home position, labeling the link joints and assigning the frames using algorithms. The details of the step-by-step frame assignment will be we are going to see that. Okay, so let me draw the frames here. So we'll be having a base frame. So base frame will be having Z0. Okay, so the axis will be traveling. So we'll be having a joint axis too. So we'll be having Z2, sorry, Z1. So here the rotation is like this, so that's why we'll be pointing Z0 in the upward direction. Later Z1 will be in the prismatic portion, so it is moving like this, so we'll be pointing in the upward direction. Later, since the joint is acting in a moving in this direction, so we have to assign the z-axis like this. Okay, and the last one will be attaching the frame to the tool position, that is like this. Okay, so later we have to assign the x-axis. So x-axis we can we have a rule that x-axis must be perpendicular to z-axis, as well as it must be perpendicular to whatever the x-axis that we are assigning, that must be perpendicular to the next frame also. Okay, so if we assign the x-axis like this and like this, that won't be perpendicular to this one. That's why I am assigning x-axis in the outside. Okay, towards outside of the frame. Okay, it's not x1, x2. Okay, it's 3. Okay, we can assign y-axis or else we can't. Okay, just in order to complete the figure, I am assigning y-axis also. Y0, y1, this will be the y2, y3. Okay, so this is how we will be assigning the frame. Okay, okay, so this is how we can assign the frames. Okay, so later frame assigning is completed. Later we have to go for DH table. Okay, we have to draw the DH table here. For drawing the DH table, we have some rules. Okay, so remember those rules. Let me write it again. AI is equal to distance from zi to zi plus 1 measured along xi. Okay, next alpha I, angle of twist from zi to zi plus 1 measured along xi. Okay, di is nothing but distance from xi minus 1 to xi measured along zi, and the last one theta I, angle from xi minus 1 to xi measured along zi. Okay, so these are the 4 rules that we need to follow, okay, while you are framing the DH table. Okay, so the DH table consists of the first one will be the links. So we have 1 2 3 links: revolute, prismatic and prismatic. Okay, AI, alpha I, di and theta I. Okay, these are the 4 things that we need to find out in order to complete the concept of DH table. Okay, so the first one, the distance from, so first for the first 2 things, okay, we will be calculating as 0 to 1, 1 to 2, 2 to 3. Okay, so first 2 we will be taking as I is equal to 0, and next we will be taking as I is equal to 1. Okay, so for I is equal to 0, so let us go for the DH table here. So I is equal to 0, so distance from z0 to z1, okay, z0 to z1 measured along the x-axis. So we will be measuring along x-axis z0 to z1. So since they both are in same plane, so I will be having the link length will be 0. Okay, so as in the question it has mentioned as angle. Okay, so that will be theta 1. So okay, so that is in the question itself. Okay, so next, the angle of twist from z0 to z1 measured along x-axis. So there won't be any angle of twist is not there, so that's why I'm taking 0. Next, dA. So the dA is nothing but distance from x0 to x0 to x1 measured along z1. Okay, so along z1, so we will be measuring the distance from x0 to x1. So x0 to x1, so we will be measuring the distances. Okay, so since they both are in the, since in the question itself he has mentioned as joint axis 2 to 3 will be having d2 length. Okay, so we don't have any distance from joint axis 1 to 2, so that's why I am giving as 0. Okay, so theta I, so the angle from x1 to x0 to x1 measured along z axis, so x, okay, So x0 to x1, x0 to x1 will be having an angle of theta 1. Okay, so theta 1 will be the angle. Okay, so the first link is completed. So the next one will be distance from. So next we will be taking as I is equal to 1 and I is equal to 2. Okay, so see here. So in order to calculate the AI, the distance from Z1 to Z2 or measured along x-axis. So Z1 to Z2. So since both the origins are in the same plane, so we don't have any length here. Okay. So next one we have the angle of twist from Z1 to Z2 measured along xy. So x1. So we'll be having, in order to reach Z1 to Z2, we must have some angle of twist. So that is, it is moving to 90 degrees. That is, it is moving in clockwise direction. Clockwise direction means that is minus 90. Okay. So the next one, so the distance from x x1 to x2 measured along the z2. Okay, so x1 to x2. So the distance, here is mentioned as, d2. Okay, x1 to x2, the distance between the x1 to x2 measured along z2. Okay, so the angle from x1 to x2 measured along z1, sorry, x1 to x2 measured along z2. So angle, what is the angle here? So we don't find any angle because it is a prismatic joint. Okay, x1 to x2 both are in the same planes, so we don't have any angle here. Okay, and the last one will be the link 3. So we have the distance. So we'll be taking I is equal to 2 here and I is equal to 3 here. Okay, so the distance from z2 to z3 measured along x2, z2 to z3. Okay, so since both are in the same plane, so we don't have any distance. Okay, so next, angle of twist. So z2 and z3 are in the same line and no need to get any offset distance, so we'll be having 0. Okay, so the next one, the distance from x2 to x3 measured along zi. So z3, distance from x2 to x3, okay, so the distance here is mentioned in the question as d3. Okay, so we'll be taking as d3. Okay, so the angle of from x2 to x3 measured along z3. Okay, so we don't have any angle since it is a prismatic joint, so here we will be giving as 0. So with this we have completed the DH table. Okay, and the last step is the transformation. So for transformation we have the formula as AI is equal to cos theta I minus sin theta I cos alpha I sin theta I sin alpha I AI cos theta I, right, sin theta I cos theta I cos alpha I minus cos theta I sin alpha I AI sin theta I 0 sin alpha I cos alpha I di 0 0 0 1. So this is the formula we are having in order to solve the this is the formula we are having in order to solve the transformation. So we have to keep the values of each link in this formula, and we have to solve the entire thing. Okay, so just try to put the data in the given formula and tell me the answer. So after first transformation, that is transformation of first frame with respect to 0th frame, so I will be getting an answer of cos theta 1 minus sin theta 1. So I am not writing the theta, just placing 1 here. Just c1 means cos theta 1 sin theta 1, 0 0 sin theta 1 cos theta 1, 0 0 0 0 1 0 0 0 0 1. Okay, so if any one of you got a different answer, let me know. Okay, so let us go for the second frame. So next frame will be, okay, so transformation of first frame with respect, sorry, second frame with respect to first frame, that is equal to, I have got, after placing the values of second link, so second link I have got an answer of 1 0 0 0 0 0 1 0 0 minus 1 0 d2 0 0 0 1. Okay, so the third transformation, that is t3 with respect to second frame, after placing the values in the given formula, I will be getting 1 0 0 0 0 1 0 0 0 0 1 d3 1 0 0 0. So these are the three frames that I have got. So we need to multiply all the three frames, and we must get the overall transformation matrix for the manipulator by multiplying the link transformation matrices. So I have got the final transformation, that is transformation of third frame with respect to 0th frame. So I have got an answer of cos theta 1 0 sin theta 1 minus sin theta 1 minus d3 sin theta 1 sin theta 1 0 cos theta 1 d3 cos theta 1 0 minus 1 0 d2 1 0 0 0. Okay, so this is the final frame that I have got. So just check the answers with your answers and let me know if any one of you got a different answer. Okay, let us go to the next problem.